Okay, today we are moving on to section 5.5, which I hope will be a review of Algebra 1. The reason why we had to drill factoring in the previous section is so that we can solve quadratic equations by factoring. And so I've got some examples. As you can see, this first example, ones like this, will help you with problems 1 through 6 on your assignment. And so here's my quadratic equation, and my first move always, if I'm solving by factoring, which my directions tell me that I am, you need to make yourself a note here. Always, if necessary, you need to make the equation equal 0. And of course that is necessary in this case, so my first move before I do anything else is to subtract 18 from both sides. And I want to make sure that on the left side that I'll be factoring that the equation is in standard form. Okay? Now it's pretty much a review of how do I factor. I always look for a GCF first. You need to train yourself to do that. But there is no GCF here. So now I'm left with the question, can I factor this as two linear binomials multiplied together? So if I can, then that means there should be factors of negative 18 that add up to positive 7. So anybody want to help me out with the factoring? Sydney? 9 and negative 2. Okay, so Sydney, how would I write the factoring then?
X plus 9, x minus 2.
All right, very good. So the great thing about factoring, which again is just another way of writing this expression using multiplication, the great thing about being able to factor is it makes the solution easy to find. Here's something that you need to keep in mind going forward. This will be true throughout the rest of your math days. The degree of your equation, this is degree 2. We already know that, it's quadratic. The degree of the equation will tell me how many solutions I'm solving for. So I know that when I solve a quadratic equation, I should be coming up with 2 solutions. And the way I come up with those solutions, now you don't have to show what I'm about to do, but I just want to make sure you understand how we come up with the solutions. I'm going to let each of these individual factors equal 0 and solve for x. So one of my solutions will be x is negative 9. The other solution will be x is positive 2. Okay, looking ahead just a little bit, in chapter 6 we're going to be solving polynomial equations. Some of them will be 4th degree. Well, if I have a polynomial in 4th degree, how many solutions am I looking for? Yes?
4.
4. Okay, so always let the degree of the equation guide you toward the number of solutions that you're supposed to find. And that's going to be very important when we start doing this, and I'll explain in just a minute, because I have some people that they don't keep this principle in mind, and it causes them to miss some easy points when they're solving by taking square roots, but that'll be in just a little bit. All right, do I have a helper for number 2? Can somebody walk me through? What would you do first here, CJ?
Subtract 6 from both sides.
Okay, very good. He said subtract 6 from both sides. Set the equation equal to 0. Make sure it's in standard form. All right. CJ, I'll let you stay with that.
Find the greatest common factor of 2.
Okay. He said to factor out a GCF, which is 2.
So x squared plus 2x minus 3
Awesome.
equals 0.
All right. Very good. All right. Let me throw this to somebody else. Who wants to factor this trinomial? Emma.
It would be x plus 4, well, 2 times the quantity, x plus 3, and then x minus 1.
Very good. That equals 0. Now I had some people ask at this point, well, what is the 2? What am I doing with the 2? Well, remember, what is factoring? Factoring is another way of writing this expression using multiplication. We've broken this up into 3 factors. But what am I solving for? I'm solving for x. So the 2 was necessary to get me to a prime factor expression, but ultimately my goal is to solve for x. So one of my solutions will be x is -3. What's the other solution? +1. And we're done. So follow the directions carefully. Some of the directions will say solve by factoring, and other directions will say solve by finding square roots, and that will be problems 7 through 12. When we solve by finding square roots, first of all, let me see if you can pick up on how this equation is different than the previous 2. Anybody want to raise your hand, and what do you notice as being different? Emma.
It already equals 0.
Okay, that's true. Already equals 0. There's something else that's different. Austin? No linear term. Okay? So if there is a linear term, then you're going to have to solve by factoring. Without the linear term, in some cases we'll have a choice, but the directions are going to tell you to solve by square roots. And so this is, when you're solving by square roots, it's going back to what you're already familiar with. We're basically isolating the variable using reverse Pemdas. Okay? Order of operations in reverse. So let's take a look at all the things that are being done to x here. There's really, if we look at PEMDAS, there's 3 things that are happening to x. Gwen, give me 1.
It's being squared.
Okay, x is being squared. What's another one?
It's being multiplied by 7.
Multiplied by 7, very good. And yes, CJ.
Subtraction.
Okay, subtraction. So we have those 3 parts of PEMDAS that we've got to undo in reverse order. So which of those would we undo first? Subtraction. Okay, so my first move is to add 343 to both sides. Now I'm left with multiplication and the exponent. If we're following reverse PEMDAS, which would I undo first? Okay, and we undo multiplying by 7 with division by 7. And I believe that's 49. Okay? And obviously, all that's left is I have to undo raising x to the second power. And the way I do that is, well, there's really 2 different ways, but I'm going to take the square root of both sides. Now, I want to go back to a statement that I made earlier. The degree of the equation tells us how many solutions we should end up with. All right, if you'll keep that in mind, that will help prevent this very common mistake. I have a lot of people that will come to this conclusion. Well, what's wrong with that? Bradley?
Square root of 49 also -7.
Well, I guess what you're saying is if we replaced x with -7 and square it, we would also get 49. Okay? And just keep in mind, I'm ultimately supposed to come up with 2 solutions. Well, how many have I written so far? I've only written 1. So here's what I want you to do to drill this, because it's easy to forget. Anytime you take the square root of both sides of an equation, like we've done here, I want you to include plus, minus. So there's a couple of things that we're going to try to do to prevent this very common mistake. Number 1, keep in mind you're supposed to be finding 2 solutions. And if you just write the positive down, you haven't written 2 solutions. And then we're just going to drill this. I want you to make this part of showing your work. Square root of both sides, and then include plus minus in front of the number that you're taking the square root of. Okay, let's try another one of those. What would I do first here? Emily,
Divide by 3.
divide by 3. That gets me to x squared equals 9.
You find the square root of x squared and 9.
Okay, square root of both sides, and what am I going to include?
Plus or minus.
Plus minus.
So it's x equals 3 and x equals
Okay,
negative.
and I'm okay with you writing your answer as x is plus minus 3, instead of writing it out x twice. All right, everybody good? Pretty easy. I think I just got one more example, and then I want to set you up on one word problem, and then I'm going to give you the rest of the time. Adam, what would you do first in this problem?
Did you add 25?
Very good. He said add 25 to both sides. All right. Allie, what would you do next?
You would divide by 4.
Okay, you could divide by 4. In this particular case, you have an option, but we'll go with Allie's suggestion. She said divide by 4, which gets us to x squared is 25 fourths. All right, and let's see. Caitlin, what would you do next?
You would find the square root.
Square root of both sides. And don't forget, plus minus. So what is the square root of the fraction 25 fourths? Emma?
5 halves.
5 halves. You just do the square root of both numbers, and we're done. Yeah?
So do you still put the plus or minus, like, okay, after you get the square root of both numbers, do you still put the plus or minus even though you don't have the square root though?
Yes.
Okay.
Yeah, the plus minus is really, that's, your answer is going to be both the positive and the negative square root.
Okay.
Yeah, and that shows 2 answers, which is, again, what we're supposed to come up with. All right, good question. Anybody else have a question? Okay, on page 266, I want you to turn there, and I want to just set up this word problem number 19. This is your whole assignment. I'm not going to do number 19 with you, but I just want to set it up. Because for word problems, this tends to cause some anxiety for some people. And number 19, you're given, this is a smoke jumper. A smoke jumper jumps from a plane that is 1,700 feet above the ground, and they give you a function that basically describes his height above the ground after so many seconds. And they tell you in the problem that y represents height and t represents time in seconds. Okay. I just want to set this up. Letter A. Who's looking at letter A? CJ, can you read that off, please?
How long is the jumper in free fall if the parachute opens at 1,000 feet?
Okay, so in other words, what is t? What is the time? How long is he in the air? If his height above the ground basically is 1,000 feet. So again, y represents his height. So if I'm told he's 1,000 feet above the ground, I'm going to let 1,000 represent y. Okay? I have no linear term. So basically, I need to set this up so that I can solve by taking square roots. And you'll definitely want to use your calculator, and I'll let you take from here. Now, these are not going to come out to be nice integers. They're going to be decimals. And I just want you to round to the nearest 100, sorry. Round to the nearest 100. And letter B is very much the same, just a different number for height. Okay? So everybody, you think you got it? So that's your whole assignment. I'm going to give you the rest of the time. Maybe you can get at least half of these done before you leave. And I'll be available for questions if you have any.